5-4, point slope form. Our objective for this section is to write and graph linear equations using point slope form. Our essential understanding is that you can use the slope of a line and any point on the line to write and graph an equation of the line. Any two equations for the same line are going to be equivalent. So in our previous section, we focused on slope-intercept form, where we have y is equal to mx plus b. So in this equation, right, we had the slope, m, and we had the y-intercept. Okay? Now we're going to focus if we just have a different point that's not the y-intercept, something different. So that's what this says. You learned how to write an equation of a line by using its y-intercept. In this lesson, we will learn how to write an equation without using the y-intercept. And to do that, I'm going to need an equation. So the point slope form of an equation of a non-vertical line with a slope of m through x1, y1, through that specific point is y minus y1 equals m times x minus x1. And if we look at this formula, y and x are my variables, y1, x1s are my x and y coordinate from the point on the graph, and the slope is my slope, rise over run. Okay. And when we use this formula, x1, y1 represents the specific point, the specific y coordinate, x coordinate. X and y represent any point and are just general variables. Okay. This formula comes right from the slope formula. So if we have a point on the line and the line's slope, we can use this definition to derive the point slope form. So I start with the formula for slope, y2 minus y1 over x2 minus x1. I switch one coordinate, x2, y2, with general points. So let xy be any point on the line, and we're going to substitute xy for x2, y2. Now all we have to do is multiply both sides by the denominator. Multiply both sides by x minus x1. And we have our formula for point slope. Okay, so let's try to use this formula now. So a line passes through negative 3, 6, and has a slope of negative 5. So what is the equation of this line? So my equation is y minus y1 is equal to m times x minus x1. And plugging in my numbers, I have y minus 6 is equal to the slope, negative 5, times x minus negative 3. And of course, I can simplify this by minus a minus, turns that into a plus. So y minus 6 is equal to negative 5 times x plus 6. Now, this is point slope form of the line. If I wanted to, I could change this to slope intercept form. And I could do that by distributing the 5. So y minus 6 is equal to negative 5x minus 30. And add 6 to both sides. So y would be equal to negative 5x minus 24. Okay. So either one of these is the equation of the line. They're just both in different forms. Okay. Let's try a guided problem. Line passes through 8, negative 4, has a slope of 2/3. Write an equation in point slope form of the line. So y minus y1 is equal to m times x minus x1. So just replace my variables with the numbers. Oops. So let's get rid of this real quick. Sorry about that. we go. Okay, so let's just replace my variables with their numbers. So y minus negative 4. Y minus negative 4 turns into plus 4 is equal to 2/3 times x minus 8. Okay. So what is the graph of the equation y minus 1 equals 2/3 times x minus 2? Well, I have a point and I have the slope. And with that, my point, right, x1 comma y1 is going to be 2 comma 1. Positive 2 comma 1 because I can see in here in my equation I have minuses. So I put a dot at 2, 1, which is right here. Then the slope, 2/3, tells me to go up 2, right 3, or down 2, left 3. And now I have an equation down 2, left 3 again. I have my line. Okay. Let's look at a got it problem. What is the graph of the equation y plus 7 is equal to negative 4 or 5 times x minus 4? Now I could go through the trouble of changing this to slope-intercept form if I wanted to, which I don't because it looks like too much trouble, and I'm going to get a fraction. So I'm going to stick with the same method. Here are the coordinates of my point. So my point, which would be x1 comma y1, would be 4 comma negative 7. Okay, we're going to take the opposite signs that we see here with this particular formula. So I put a dot at 4. 1, 2, 3, 4, negative 7. 1, 2, 3, 4, 5, 6, 7. Then my slope tells me to go down 4, up, or sorry, down 4, right 5, or up 4, left 5, but not down 4, left 5, because then this would be a positive slope. Okay? So because I can't really go down 4 without going off the graph, let's go up 4, 1, 2, 3, 4, and then left 5, 1, 2, 3, 4, 5. And you can see that my line is going down, which is what I expect from something that has a negative slope. Okay? We can write the equation of line given any 2 points on the line. First, use the 2 given points to find the slope. Then, use the slope and one of the points to write the equation. So, if I look at this equation right here, right, I'm going to have to find, if I want to use point slope form, I'm going to need to use a point and the slope. So let's use this point right here and the slope. So in order to figure this out, I could figure this out algebraically, or I could just count. So if I wanted to use the slope formula, I could say y2 minus y1 over x2 minus x1 is equal to the slope. Or I could start at this point and say the slope is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So the slope is going to be 7 over 3. Up 7, right 3. And as I look at this line, there was no other real good point to pick to calculate the slope. So my equation, y minus y1, is equal to m times x minus x1. And then I fill in my coordinates. And like I said, let's use the first coordinate up there, 1 comma 4. So that would be y minus 4 is equal to 7 over 3 times x minus 1. to my got it problem. In the last step of problem 3, use point -2 comma 3 instead of 1, 4. So instead, that would be y plus 3 is equal to 7 over 3 times x plus 2. Well, if I look at these two equations, it seems like they are different. Okay? But rewrite the equation in problem 3 in part A in slope-intercept form and compare the two. So let's do that. Let's change this first equation to slope-intercept form. So this would be y minus 4 is equal to 7 over 3x minus 7 over 3. Then, when I add 4 to both sides, I get a fraction, yes. So that is minus 7 over 3 plus 4 gives me y is equal to 7 over 3x plus 5 over 3. Okay, let's go down here. And the same thing. Y plus 3 is equal to 7 over 3x plus, and this is 2 over 1, so that becomes 14 over 3. Subtract 3 from both sides, and we get y is equal to 7 over 3x plus 5 over 3, okay, which is the same. Makes sense, because these are the same line. So if we put things into slope-intercept form, we can see that it does not matter which point we pick to use slope-intercept form. All that matters is that we plug them in correctly. Be careful of the signs. So we can also use a table to write an equation. So the table shows the altitude of a hot air balloon during its linear descent. What equation in slope-intercept form gives the balloon altitude at any time? What do the slope and the y-intercept represent? Well, since I don't know the y-intercept, I'm going to need to use point slope form. So, because I don't have a picture, let's use the formula. So the slope is y2 minus y1 over x2 minus x1. And let's use that point and that point. So we have 590 minus 640 over 30 minus 10, which gives me a negative 2.5. Okay? So when we plug this in, we can use any point we want. Let's pick the first one. So that becomes y minus 640 is equal to negative 2.5 times x minus 10. Now, distribute, and we get y minus 640 is equal to negative 2.5x plus 25. Adding 640 to both sides gives me y is equal to negative 2.5x plus 665. Now my equation is in slope-intercept form. And what do the slope and the y-intercept represent? The slope represents, right, rise over run, meters per second. Negative means we're going down 2.5 meters per second. 665 is where we started. That represents the initial altitude of the balloon in meters. Okay? So let's try one more got it problem. So the table below shows the number of gallons of water y in a tank after x hours. The relationship is linear. What is an equation in point-slope form that models the data? Okay, well, same thing. Looks like after a certain number of hours, we're filling up the tank. We're not taking water out of the tank. So my answer, best to use the easiest points, these two. So we're going to first find the slope, which would be 4570 minus 3320 over 3 minus 2. Nice. Right. Subtract, and we get 1250 over 1. So it's 1250. So using the first point, we have y minus y1 is equal to the slope times x minus x1. Okay. What does the slope represent? So like we said, this represents rise over run, gallons per hour, y over x, the number of gallons you are adding to the tank every hour, 1250. And then finally, write the equation in slope-intercept form. So this is going to be the same technique that we used before. We're just going to distribute 1250 minus, 1250 x minus 2 times 1250 gives me 2500. And then add 3320 to both sides. So we get y is equal to 1250x plus 820. What does the y-intercept represent? The initial number of gallons of water in the tank. So this tank didn't start at 0. We started at 820 gallons. Okay, so it was not empty when we started. So our lesson check, let's go this real quick. So what are the slope and 1 point on the graph of this? Well, the slope is 4 over 9. And 1 point on the graph is -7, comma 12. Right? -7, comma 12. Point, slope. What's the equation of the line that passes through the point? Okay, so we have y minus -8, so that turns positive. Slope x minus 3. Okay. What is the graph of the equation? So we have our slope, we have a point, plot the point, graph. The slope is 3 over 1. So we would start at -2, comma 4, and I would go up 3, right 1. Okay. This is the most common kind of problem, number 4. The equation of the line that passes through the points -1, 2, and 2, 4. So first find the slope. So it would be 4 minus -1, or sorry, 4 minus -2, which turns into a positive 2, and 2 minus a -1, so that's 6 over 3, which is 2. So then I can pick either point I want. I pick the positive points, a little easier, don't have to think too much about it. Y minus 4 is equal to 2 times x minus 2. Okay, and then of course, if I wanted to put it in slope-intercept form, it would be y minus 4 is equal to 2x minus 4, add 4 to both sides, so y is equal to 2x. So what features of the graph of the equation y minus y1 times equals m times x1 can you identify? Well, we can identify a slope, which is m, and a point, which is x1, y1, which is why this form is called point slope. Is y minus 4 equals 3 times x plus 1, an equation of a line through to 1? Well, if I wanted to, I can easily check. Could check the hard way by graphing and seeing if it goes through that point, or I can plug in the point and see if it works. So I could say -2 minus 4 should be equal to 3 times 1 plus 1. So negative 2 minus 4. Well, see, I did it backwards. That's why it didn't look like it was going to work. Y, 1 minus 4 is equal to 3 times negative 2 plus 1. Much better looking. That's negative 3. Negative 2 plus 1 would be 3 times negative 1, which is also negative 3. So this does work. So it is a point going on that line. Can any equation in point-slope form also be written in slope-intercept form? Yes, because y minus y1 is always equal to m times x minus x1, and I can always distribute no matter what. That's m times x minus m times x1, and I can subtract this from both sides. So y will always be the slope times x minus the slope times x1 minus y1, no matter what. Okay? So that was 5-4 point slope.